Let's do that because that was a suggestion. Okay. Well, the mass of water is 1,500. 4.184. Then the final temperature of water would be what? Is that what we're looking for?
Yeah. That's what
X minus the initial temperature of 75. So that'll take care of one water. Equals 75, 4.184. The final temperature of that water is what we're looking for, right? Minus the initial temperature, which would be what?
Actually, the 75 would be the 71 on the left side of the equation.
There. That's what you want to do? Now, which side's negative?
Water's losing energy.
Isn't that the temperature of the ice? And the ice is on the red.
Now, it wouldn't be the temperature of the ice. It can't be.
Well, okay. Never mind.
I think the left side's negative.
I'm kind of wanting to go with negative 71, but let's see here, right? Negative 1,500 times 4.184. All right. Negative 6276 plus 445596 Now it's telling me that the X is 67.6 degrees centigrade. So you want to be done there then? You got the solutions manual? What's it say? 68. Oh, thank God. Okay. That's good. Number 29, 68. Wonderful. All right, so the way of mixing the ice, so basically it's just like a problem from chapter 4, but you have to do this first. Get the ice melted because there's two specific heats. Okay, thank you, Sandy. That was awesome. Are we good? Naturally, there is a star beside that one. All right, let's do another one. Let's do number 30. Is it going to be the same way? Yes? No? All right, so let's try number 30. If 9560 joules of energy were absorbed by 500 grams of ice at 0 degrees centigrade, what would be the final temperature? Okay. Well, first, we're going to have to start applying energy. All right. So what would happen if we took ice, which is a solid, to liquid water? 0 degrees centigrade here, 0 degrees centigrade here. How much energy would that take? Well, Q equals mass, which is 500 grams, times the heat of vaporization, 335 joules. So if we did that and changed no temperature, All right. What we would do is take 500 times 335, and that is going to be 167,500 joules. So if we applied all that energy to this ice, what would the temperature be? Now look, first off, if you applied 167,000 joules of energy, you would go from a solid to a liquid, but you would still be at 0 degrees centigrade. Well, what would happen if you applied 9,000 joules of energy? You would still be way less than that, right? So the temperature should still be 0. Does that make sense? Am I interpreting the problem right? I mean, let's read it here. It says, if that much joules of energy were absorbed by 500 grams of ice, what would be the final temperature? 0. That's the answer. 0. So it would have to go over 168,000 joules before the temperature would still be rising. There would still be ice left over. So if we were running this experiment on the table, this was ice, there would be a small little puddle underneath the marker. But the marker would still be ice. Thank you again, Sandy, for a wonderful problem. All right, 54. All right. How many joules of energy would be liberated? That means given off by condensing 50 moles of steam at 100 degrees centigrade and allowing the liquid to cool to 30 degrees centigrade. Okay, so here's what we're going to do. Let's draw a picture. Ice, liquid, 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 steam, steam, steam. Temperature, energy. Okay, it says taking steam at 100 degrees centigrade, that is here, down to 30 degrees centigrade, that is here. How much energy? Well, it says that we're starting out with 50 moles of steam. I know that in 1 mole of steam, there's 18 grams of steam. Okay, I'm doing this to get a mass because, of course, all these things are dependent upon mass at 50 times 18. So that's going to be 900 grams. Okay, we're working backwards here. The first thing we're going to do is we're going to say, what is the heat of vaporization of water? So we're going to a table to find that. What would that be? Heat of vaporization of water.